The belt feed mechanism had failed, again. For the third time that morning, the MG-42 sat silent, while American artillery walked closer. The noise was deafening, the panic immediate, and the mathematics of survival brutally simple. Every second without that gun operational was 1 second closer to being overrun. His squad leader was screaming at him to fix it. The standard manual said, disassemble, diagnose, replace parts. That would take 12 minutes. They had maybe 3. So Private Friedrich Wegner did something that would get him court-martialed if it failed, and ignored if it worked. He grabbed a length of wire from a destroyed field telephone, wrapped it around the feed mechanism in a pattern that made no technical sense whatsoever, twisted it tight and slapped the cover closed. 60 seconds later, the gun was firing again. Not just firing, screaming. 1,200 rounds per minute of sustained fire that would hold that position for 6 hours straight. Chew through 18,000 rounds without a single stoppage and create a sound so distinctive that American troops across the line would later report they thought the Germans had deployed a new weapon. They hadn't deployed anything new. They had just witnessed what happens when desperation meets intuition. When a soldier with no engineering training accidentally solves a problem that German weapons designers had struggled with for months, and when a field repair so crude that it violated every technical manual somehow worked better than the original design. This is the story of a belt feed fix that should have been a footnote but became a legend, copied across the Eastern and Western fronts, incorporated into official field manuals after the war, and studied by military engineers for decades. But it is really about the moment when the gap between engineering theory and battlefield reality became so obvious that even the Wehrmacht had to admit that sometimes the best solutions come from the people actually pulling triggers under fire. And what it reveals about innovation, desperation, the difference between elegant solutions and working ones, and why the worst moment of your life might force you to invent something that changes everything. To understand what Private Wegner did on that morning in September 1944, you need to understand what he was working with and what he believed about it. The MG-42, the Maschinengewehr 42, was supposed to be the pinnacle of German engineering applied to automatic weapons. 1,200 rounds per minute, a rate of fire so high it didn't sound like individual shots but like tearing fabric, like a buzzsaw, like something mechanical and inhuman. The weapon had been in service since 1942, had proven itself across every theater Germany fought in, and had earned a reputation that made Allied soldiers dive for cover at the first hint of its distinctive sound. The doctrine around it was simple. The MG-42 was the center of German infantry tactics. Everything else, the riflemen, the submachine gunners, the grenadiers, existed to support and protect the machine gun. Lose the gun, lose the position. Keep the gun running. Hold anything. This wasn't just tactics. This was belief, drilled into every Wehrmacht soldier from basic training forward. The gun was supreme, the gun was reliable. The gun was German engineering at its finest. Except it wasn't. Not entirely. Because the MG-42 had a problem that the manuals didn't talk about, that the designers had tried to engineer around, and that every machine gunner in the field knew intimately. The belt feed mechanism jammed, not always, not even frequently under ideal conditions. But ideal conditions didn't exist on the Eastern Front in 1944, didn't exist in the hedgerows of Normandy, didn't exist anywhere that mattered. Mud, dust, worn components, slightly bent feed trays, ammunition belts that weren't perfectly straight, and the mechanism would bind, the rounds wouldn't feed smoothly, the gun would fire 3 or 4 shots, then nothing. Clear it, try again, same problem. And when it happened, when that mechanism failed in the middle of contact, you had a very expensive 12-kilogram paperweight and a position about to be overrun. The standard solution was methodical, engineer-approved, and fatally slow. You were supposed to open the feed cover, remove the belt, inspect the feed tray for damage or debris, check the feed pawls for proper movement, verify the belt wasn't twisted, reassemble, and test. Done properly, by a trained armorer with proper tools and no incoming fire. This took 8 to 10 minutes. Done in a fighting position, under artillery, by a 19-year-old private whose hands were shaking and whose squad leader was screaming at him, it took longer, often much longer. And the problem was, battles don't pause for maintenance. The American or Soviet attack doesn't stop because your feed mechanism needs troubleshooting. The enemy doesn't cease fire while you methodically diagnose tolerance issues in your feed pole geometry. So machine gunners developed shortcuts, field expedients, ways to get the gun running even if it wasn't fixed properly. You could force feed the belt manually, one round at a time, while the assistant gunner pulled the trigger. You could remove the feed cover entirely and have someone hold the belt in precise alignment while firing. You could switch to single shot mode and load individual rounds. None of these were good solutions. All of them were better than having no gun at all. This was the context Wegener operated in that September morning. A weapon that was theoretically excellent, but practically temperamental. A tactical doctrine that required that weapon to function continuously, and a situation where the gap between theory and practice was measured in incoming artillery rounds. The position they were holding wasn't strategically important in any grand sense. It was a sector of the Gothic Line in Italy, one of dozens of defensive positions the Wehrmacht was trying to hold against the Allied advance northward. The terrain was mountainous, rocky, difficult for both sides. The Germans had been dug in for weeks, long enough to build proper fighting positions, long enough to get comfortable, long enough to start believing they might actually hold this line through winter. Then the British Eighth Army decided otherwise. The barrage started at dawn, methodical and overwhelming, the kind of artillery preparation that signaled a major push. Wegener's squad, 9 men and 1 MG42, occupied a position covering a valley approach. Their job was simple in concept, nearly impossible in execution. Deny that approach to British infantry attempting to advance. One machine gun, properly positioned with good fields of fire and adequate ammunition, could do that. One machine gun that kept jamming every 50 rounds was just a target. The first jam happened 20 minutes into the barrage. Wegener cleared it using the manual procedure, got the gun running again, fired another belt. Second jam, cleared it again. Third jam. And this is when he started to understand that something was fundamentally wrong, not with his technique, but with the mechanism itself. The feed tray, the metal guide that directed the ammunition belt into the receiver, had developed a slight warp, probably from heat, possibly from a near miss during a previous bombardment, definitely enough to cause the belt to catch at a specific point in the feed cycle. The proper solution was to replace the feed tray. They didn't have a spare. The next proper solution was to carefully bend it back into alignment using specific tools. They didn't have those tools. The final proper solution was to report the weapon as non-operational and fall back to secondary positions. That wasn't an option his squad leader was willing to consider, so Wegener stared at a jammed feed mechanism and did something that every soldier in every war eventually has to do. He stopped thinking like someone who had read manuals and started thinking like someone who needed this thing to work in the next 60 seconds, or people were going to die. The wire he grabbed came from a destroyed field telephone in the bunker. Communication wire, meant for transmitting voice signals, copper core with fabric insulation, absolutely nothing to do with machine gun operation. He didn't have a plan, he didn't have a theory. He had a warped feed tray that was causing the belt to catch, and he had wire. And somewhere in the back of his mind was the idea that if he could create pressure on the feed tray from the outside, he might be able to force it into better alignment. So he wrapped the wire around the feed cover assembly, not following any engineering logic, but working purely on intuition, wrapping it tight enough to create tension, positioning it so the pressure pushed the tray in what felt like the right direction. He twisted the ends together with pliers, slapped the cover closed, loaded a belt, and told his assistant gunner to fire. The gun fired. 1 round, 2, 10, 20, 50. The belt ran through without catching. Wegener and his assistant gunner looked at each other with the same expression soldiers get when something impossible just worked. Then they loaded another belt, and another, and for the next 6 hours, through the entire British assault on their sector, that gun fired continuously without a single feed stoppage. 1,200 rounds per minute. Times 6 hours is 432,000 theoretical rounds. They didn't fire continuously. No gun could sustain that. But they went through 18,000 rounds that day. 18,000 rounds without the feed mechanism failing once. The sound was constant. That distinctive MG42 roar that made it sound like the air itself was tearing. British infantry advancing up the valley heard it and went to ground. Officers who had been briefing their men on suppressing the German machine gun position had to revise their estimates of how much fire they were facing, and the whole time, that crude wire wrap held. When the attack finally broke off at dusk, when the British fell back to consolidate and try again tomorrow, Wegener's squad leader came to inspect the gun. The barrel was glowing, would need to be replaced. The mechanism was filthy with carbon buildup, and wrapped around the feed cover was this twisted mess of communication wire that looked like something a child had done, that violated every principle of proper weapons maintenance, and that had just kept a position from being overrun. The squad leader stared at it for a long moment. Then he asked Wegener to show him exactly how he had done it. Not because he thought it was a good idea, not because it made any technical sense, but because it worked, and in a war where Germany was running out of everything except enemies, things that worked mattered more than things that were correct. Word spread the way useful information always spreads in combat units. Laterally, soldier to soldier, gunner to gunner, faster than any official communication. Within a week, machine gun crews across that sector of the Gothic Line were wrapping their feed mechanisms with wire. Some used communication wire. Others used fence wire, or wire pulled from destroyed vehicles or whatever they could find. The pattern varied. Some crews wrapped it the way Wegener had, others developed their own variations. But the core idea was the same. External pressure on the feed cover to keep the feed tray in better alignment and prevent the belt from catching. And it worked. Not every time, not for every gun. Some feed mechanisms were too damaged for any field expedient to fix. But for guns that were developing early-stage feed problems, for mechanisms that were starting to wear but weren't completely failed, that wire wrap bought time. It turned a gun that jammed every 50 rounds into one that could run through 3 or 4 belts before needing attention. In defensive positions where every minute of sustained fire could mean the difference between holding and retreating, that mattered enormously. But here is where the story gets interesting, where it stops being just a clever field repair and starts revealing something deeper about how militaries actually innovate versus how they think they innovate. The official Wehrmacht response to feed mechanism problems in the MG42 was to issue updated maintenance procedures and recommend more frequent inspection of feed components. The engineers at Grossfuss, the primary manufacturer, were working on improved feed tray designs with tighter tolerances. The Waffenamt, the German Army Weapons Agency, was conducting studies on ammunition belt quality and its effect on feed reliability. All of this was proper, methodical, engineer-driven problem-solving. All of it was also too slow, too dependent on manufacturing capacity Germany no longer had, and too disconnected from what was actually happening at the front. Meanwhile, soldiers were fixing the problem with wire. No testing protocols, no engineering studies, no official approval, just desperate men making guns work, because the alternative was unacceptable, and the gap between those two approaches, between the systematic engineering solution and the field expedient that actually saved lives, tells you something important about organizations under stress. When the official solution takes months and the immediate problem is killing people today, soldiers will invent their own solutions. They won't ask permission. They often won't even report what they have done until long after it has proven itself. And those solutions, crude as they might be, often work better than the elegant fix that arrives too late to matter. This is what was happening across the German military by 1944, not just with machine guns, but with everything. Tanks that were supposed to have factory repairs were being fixed, with cannibalized parts from destroyed vehicles. Aircraft that needed depot-level maintenance were being kept flying with field modifications that would horrify the designers. Weapons that were meant to be replaced when worn were being rebuilt, improvised, and kept in service through sheer ingenuity because new ones weren't coming. The German military was eating its seed corn, and soldiers like Wegener were figuring out how to make that corn grow anyway. The first time a captured MG42 with the wire wrap modification showed up in Allied intelligence reports, analysts didn't know what to make of it. The weapon had been recovered from a German position that had finally been overrun, and British ordnance experts examining it found this crude wire arrangement on the feed mechanism. Initial assessment: field damage. Probably from a near miss, ignore it. But then more examples started showing up. Multiple guns, different units, all with similar wire wraps on the feed mechanism. That got attention, If this was widespread, it meant something. Either the Germans were experiencing systematic feed mechanism failures and couldn't get proper repairs, or they had discovered some kind of improvement and were implementing it at the field level. Either interpretation was useful intelligence, so Allied ordnance teams started testing captured MG-42s with and without the wire modification, and they found something interesting. Guns with the modification had measurably better belt feed reliability, especially when the feed tray was slightly out of specification. The wire wrap was applying tension that compensated for wear and minor damage. It was crude, it was inelegant, but it was measurably effective. The technical reports filed by Allied analysts are fascinating because you can read the cognitive dissonance in them. On one hand, this was clearly a field expedient born of desperation, the kind of modification you make when you can't get proper parts. On the other hand, it worked. It solved a real problem. And it had been invented not by engineers but by soldiers who needed guns to function and couldn't wait for official solutions. The Americans, who were having their own belt feed issues with the Browning M1919, started experimenting with similar tension modifications. The British filed it away as useful intelligence about German maintenance capacity degradation, and somewhere in the files someone noted that the Wehrmacht seemed to be getting better at field innovation, while simultaneously losing the industrial capacity to do things properly. That combination was dangerous. A military that can't build new equipment, but can keep old equipment running through improvisation, is a military that can keep fighting longer than logistics models predict. Back on the Gothic line, Wegener's modification had taken on a life of its own. Other squads weren't just copying the wire wrap, they were improving it. Some crews found that wrapping the wire in a specific pattern created more even pressure. Others discovered that adding a second wire at a different angle prevented a different type of jam. A few experimenters found that inserting small shims under the wire could fine-tune the pressure for guns with specific types of feed tray damage. None of this was documented officially. None of it went through any kind of formal testing or approval process. It spread through demonstration, through gunners sharing techniques, through the organic information network that exists in any combat unit. And it worked well enough that by October 1944, the wire wrap had become standard practice in some Wehrmacht units. Not officially standard. No one had issued orders or updated field manuals, but every machine gunner knew about it. Most had done it, and new gunners were taught the technique as part of their practical training. This is how actual innovation happens in military organizations, not through official channels but despite them, spreading laterally through informal networks, adopted because it works, rather than because someone in authority approved it. The official Wehrmacht recognition of the modification came months later, too late to matter for the war, but interesting as a case study in how institutions incorporate field innovation. A report landed on the desk of an officer in the Waffenamt who had enough sense to recognize that when the same field modification shows up across multiple theaters independently, it means soldiers have discovered something worth paying attention to. He ordered a formal evaluation. Engineers at Grossfuss were given several MG-42s with the wire wrap modification and asked to assess whether it was effective, whether it caused any damage to the mechanism, and whether it could be incorporated into official maintenance procedures. The testing took 3 weeks. The results were professionally awkward. Yes, the modification was effective. It reduced feed stoppages in guns with worn or slightly damaged feed trays by approximately 60%. Yes, it was safe. The wire created tension, but not enough to damage components. No, it wasn't a proper long-term solution because it didn't address the underlying cause of feed tray wear. But yes, as a field expedient, it was better than any other short-term fix available. The recommendations were even more awkward. Officially recognize the modification, include instructions in updated field manuals, but also emphasize that it was a temporary measure and proper maintenance and parts replacement were still required. That final caveat was bureaucratic cover, a way of saying this works without admitting that the official solution had failed. The updated field manual that eventually included Wegener's wire wrap technique was published in March 1945, 6 months after he had invented it, 2 months before Germany surrendered. Most machine gunners never saw it. They didn't need to. They had already learned the technique from other gunners, had already been using it for months, already knew it worked. The manual was documentation of a solution that had already spread and proven itself. This is the institutional paradox. The organization took 6 months to officially recognize something that had been saving lives from the moment it was invented, and by the time recognition came, it was irrelevant because everyone who needed to know already knew. But the story doesn't end with the war. The MG42 design survived, was adopted by the post-war German military as the MG1 and later the MG3, and remained in service into the 21st century. And the feed mechanism modifications that started with Wegener's desperate wire wrap in 1944 were incorporated into the engineering of later versions, not the wire wrap itself, that was too crude for a peacetime manufacturing process, but the principle. External tension on the feed tray to maintain alignment, engineered into the design through improved springs, better tolerances, structural changes that achieved the same effect Wegener had created with field telephone wire. Modern machine gun designers study the MG42 feed mechanism evolution as a case study in how field experience should inform engineering. The gun that entered service in 1942 had a feed system designed by engineers working from theory. The gun that emerged from the war had a feed system refined by soldiers working from necessity. The difference in reliability was measurable and significant. And the process by which that refinement happened, the lateral spread of field innovation faster than official channels could move, became a model for how military organizations should capture and incorporate battlefield lessons. The U.S. Army's after-action review process, the Israeli Defense Forces' emphasis on bottom-up innovation, NATO's rapid feedback mechanisms for equipment performance all owe something to the recognition that soldiers facing immediate problems will invent immediate solutions, and smart militaries find ways to capture that innovation rather than suppress it. There's a philosophical weight to this story that goes beyond machine gun feed mechanisms, that gets at something fundamental about how humans solve problems under pressure. Wegener didn't have time for elegant solutions. He didn't have the luxury of understanding root causes or developing systematic fixes. He had 60 seconds and a piece of wire and a problem that was about to get people killed. So he did something that made no theoretical sense, that violated every principle of proper weapons maintenance, and that worked. This is the gap between engineering and desperation, between designed solutions and discovered ones. Engineering is about understanding the problem completely, analyzing all variables, developing a solution that addresses root causes and works consistently under all conditions. That's the proper way to solve problems. But it takes time, takes resources, takes an environment where you can fail safely and iterate. Desperation is about making something work right now, with whatever is available, even if you don't understand why it works. That's the improper way to solve problems. But sometimes improper solutions that work immediately are better than proper solutions that arrive too late. The interesting question is, how many of humanity's great innovations started as desperate improvisation that accidentally worked? How many things we now consider elegant solutions began as crude field expedients? Fire, agriculture, medicine, metallurgy. How much of technological progress came from people who needed something to work and couldn't wait for someone to figure out the theory? And what does that tell us about the relationship between knowledge and innovation, between understanding and discovery? Here's what makes Wegener's story particularly fascinating. He never became famous. There was no medal, no official recognition during the war, no entry in his service record noting that he had invented a modification that spread across the Wehrmacht and saved countless lives. He was a private. He fixed a gun. He did his job. After the war, he went home, worked as a machinist, and told the story occasionally when other veterans asked about his service, but never thought it was particularly remarkable. The modification he invented was attributed to anonymous field innovation in official histories, the kind of thing that happens organically in combat units without any single inventor. And that's actually perfect, because the point of the story isn't about one soldier's ingenuity. It's about what happens when systems fail and individuals have to compensate. It's about the moment when belief in official solutions runs into the reality that official solutions don't arrive fast enough. It's about the gap between how we think organizations work, top-down, rational, planned, and how they actually work, which is bottom-up, chaotic, improvised by the people doing the actual work. Every soldier who wrapped wire around an MG42 feed mechanism between September 1944 and May 1945 was participating in the same process, acknowledging that the system couldn't provide what was needed and creating local solutions anyway. Some of those solutions worked better than others. Some became widespread. One Wegener's wire wrap became so widespread it eventually made it into official manuals, but all of them represented the same phenomenon: frontline innovation driven by necessity, spreading through informal networks, adopted because it saved lives rather than because someone in authority said it was approved. The Americans studying captured German equipment after the war wrote extensive reports on Wehrmacht field maintenance practices. What they found surprised them. Despite massive supply shortages, despite the collapse of German industrial capacity, despite losing the war, German equipment was often still functional, still in the fight, kept running through elaborate field expedient repairs that would never have been taught in peacetime. The technical term for this in military logistics is supply chain failure compensated by field innovation. The practical term soldiers used was making do. And what the analyst concluded was that an army that can make do, that can keep fighting when proper supplies aren't available, is dangerous precisely because it won't collapse when logistics models say it should. The Wehrmacht in 1944 should have been immobilized by lack of spare parts. It wasn't, because soldiers kept equipment running through improvisation. That didn't change the outcome of the war. Germany was losing for far more fundamental reasons than machine gun reliability. But it prolonged the fighting, made every advance more costly, and demonstrated that military effectiveness isn't just about having the best equipment, it's about having soldiers who can make any equipment work. The Israeli military studied these lessons extensively after 1948, when they were fighting with a mix of captured, improvised and obsolete equipment, and couldn't afford to have anything stop working just because they lacked proper parts. The IDF institutional culture of field innovation, the expectation that soldiers will find ways to keep equipment functional regardless of official supply status, owes something to studying how the Wehrmacht kept fighting long after it should have collapsed. So does the US Special Operations Force's emphasis on teaching soldiers to repair and improvise, to never assume that proper parts will be available. This is one of those historical threads where a desperate fix in Italy in 1944 influences training doctrine 70 years later, because the underlying truth it revealed is timeless. When survival depends on equipment functioning, humans will find ways to make equipment function. Let's think about what was actually happening in Wegener's mind during those 60 seconds when he wrapped wire around a feed mechanism. He wasn't inventing based on deep knowledge. He was pattern matching based on intuition. He had seen the feed tray was warped. He had some sense, probably not even consciously articulated, that external pressure might compensate. He had wire, so he wrapped it in a way that felt right and hoped it worked. This is not engineering. This is not systematic problem solving. This is something more primitive and maybe more powerful. Desperation channeled through experience into action that bypasses conscious analysis. Athletes describe this as being in the zone, that state where you're not thinking about what you're doing, you're just doing it. And somehow it works better than when you think about it. Soldiers describe it as training taking over. Muscle memory, the way your hands do the right thing before your brain has processed the situation. But this was different, because Wegener wasn't falling back on training. He was improvising something he had never been taught, creating a solution that didn't exist in any manual, doing something that would have gotten him in trouble if it failed, but which he did anyway, because the alternative was worse. That moment, that leap from "this is broken" to "let me try this thing that makes no sense," that's the moment where innovation happens, not in laboratories, not in engineering reviews, but in the gap between failure and necessity, where the cost of doing nothing exceeds the risk of doing something stupid. And here's the uncomfortable truth that militaries have always struggled with. You cannot train this. You can create conditions that make it more likely. You can build a culture where soldiers are empowered to improvise rather than punished for deviating from doctrine. You can select for people who have the temperament to try things under pressure. But you cannot create a manual that teaches someone how to invent a solution to a problem they have never encountered. That requires something that exists outside official systems, individual initiative combined with just enough knowledge to be dangerous and just enough desperation to try anyway. The Wehrmacht in 1944 had a lot of that desperation. They also still had a culture, inherited from pre-war professionalism, that valued technical competence and expected soldiers to be capable of independent action. That combination, desperation plus competence, is what creates field innovation. The reason the Soviet military of the same period produced similar levels of desperate innovation is they had the same combination. The reason more bureaucratic militaries struggled with field innovation is they optimized for compliance over initiative, which works great when supply chains function, but fails catastrophically when they don't. This is the organizational lesson. You can have efficiency or you can have resilience, but optimizing for one tends to reduce the other. A military that runs on perfect supply chains and detailed procedures is incredibly efficient until something breaks, at which point it stops. A military that runs on improvisation and field expedient repairs is less efficient, but doesn't stop when supply chains fail. Germany in 1944 wasn't trying to be resilient. They were being forced into resilience by collapse. But the capability for resilience came from soldiers who had enough training to be competent and enough autonomy to be creative. The final irony of the story is that the modification that spread across the Wehrmacht, that was studied by Allied intelligence, that eventually made it into official manuals, that influenced post-war machine gun design, started with a private who just wanted his gun to work and didn't think he was doing anything historically significant. Wegener wrapped wire around a feed mechanism because the gun was jammed and his squad leader was screaming at him and American artillery was getting closer. He didn't think, I am about to invent a field expedient that will be used throughout the German military. He thought, maybe this will work. And it did. And that's the difference between invention and innovation. Invention is creating something new. Innovation is creating something that spreads, that gets adopted, that changes how people do things. Wegener didn't set out to innovate. He set out to fix a broken gun. But because what he did worked, because other soldiers saw it and copied it, because it solved a problem that existed across the entire military, his 60-second improvisation became an innovation. He never benefited from it, never got credit, never thought of himself as an innovator. But the thing he created, that crude wire wrap pattern, outlived him. It's in museum displays of MG42s now, that distinctive wire pattern on feed mechanisms of weapons recovered from German positions. Curators note it as an example of field modification, but often don't know the story behind it. Don't know about Wegener, don't know about that morning in September when a desperate private invented something that changed how machine guns worked. That's how most innovation actually happens. Not through dramatic breakthroughs by recognized geniuses, but through small improvements by unnamed people solving immediate problems, improvements that spread because they work, not because anyone promoted them. What would have happened if Wegener's modification had failed? If that wire had broken during firing, or if it had caused a catastrophic jam, or if it had damaged the mechanism, he probably would have been disciplined. At minimum yelled at for field expedient repairs that weren't authorized, possibly court-martialed if the failure had cost lives. This is the asymmetry of field innovation. Succeed and you get ignored, fail and you get punished. Which means that for every successful field modification that spreads and eventually gets recognized, there are probably dozens that failed and are remembered only as examples of what not to do. But this asymmetry is actually necessary. If every improvised repair was encouraged regardless of outcome, soldiers would try all kinds of dangerous nonsense that would get people killed. The fact that failed improvisations have consequences is what keeps improvisation tethered to reality, what creates selection pressure for ideas that actually work. Wegener's wire wrap worked, so it spread. Other modifications didn't work, so they didn't spread. The system was selecting for effectiveness through distributed trial and error, without any central authority deciding what should be tried. This is evolution applied to technology. Random variation, field testing under actual combat conditions, and selective retention of what works. It's messy, it's inefficient, some of the trials kill people, but it's faster than any centrally planned innovation process could ever be. And in 1944, When Germany was losing the war and didn't have time for careful deliberation, that speed mattered more than efficiency. The machine gun that Wegener fixed that morning in September was probably destroyed before the war ended. Captured, blown up during a retreat, lost when positions were overrun, it doesn't matter. The physical weapon didn't survive, but the idea did. That's what makes human innovation different from animal improvisation. A crow that learns to use a stick to get food might teach other crows, but the knowledge doesn't persist beyond that local population. Humans create knowledge that spreads beyond individual experience, that gets encoded in manuals and taught to people who never witnessed the original invention. Wegener's wire wrap started as one soldier's improvisation. It became institutional knowledge. Not immediately, not officially, but eventually. And that transformation, from individual action to collective knowledge, is how civilizations advance. Every technology we take for granted, every procedure we consider standard, started as someone's improvisation. Most of those someones are forgotten. The improvisation survives. That's not tragic, that's how it should be. Ideas are more important than credit. Solutions matter more than recognition. Wegener fixed a gun. The fix worked. Other soldiers learned it. And somewhere in that transmission, the original inventor stopped mattering because the solution had become bigger than any individual. This is the price and the point of innovation. You create something that outlives you, that becomes so common people forget it was ever invented, that transforms from that thing Wegener did to that thing everyone does, to just how we do it. The ultimate success of an innovation is when it becomes invisible, when no one remembers it was ever new. So what does all of this mean beyond machine guns and wire and the tactical minutiae of World War II infantry combat? It means that the gap between how we think systems work and how they actually work is often enormous. We think innovation comes from the top, from smart people in positions of authority, carefully analyzing problems and implementing solutions. Sometimes it does, but more often it comes from the bottom, from people facing immediate problems who can't wait for official solutions and who improvise something that works right now with whatever is available. We think expertise means deep knowledge, formal training, understanding of theory and principles. Sometimes it does. But sometimes expertise means just enough knowledge to be dangerous, combined with desperation and intuition, and willingness to try something that makes no theoretical sense, but which might work anyway. We think organizations change through deliberate processes, strategic planning, top-down implementation of new procedures. Sometimes they do. But more often they change through bottom-up innovation that spreads laterally, gets adopted because it works, and eventually gets reluctantly recognized by official channels long after everyone doing the actual work has already moved on. Wegener's story is a reminder that the most important innovations often come from the most unlikely people, solving problems that experts said were hard using methods that make no sense until they work. It's a reminder that desperation is an underrated driver of creativity, that the best solutions are often the simple ones, and that sometimes the difference between success and failure is just the willingness to try something stupid because doing nothing is worse. And it's a reminder that we are all, every one of us, operating in systems that don't work quite as well as we think they do. Systems that depend on people at the bottom level improvising constantly to compensate for failures at the top. Systems that would collapse if everyone actually followed every rule and waited for official solutions to every problem. That machine gun crew in Italy in 1944 was holding a position not because German engineering was superior, or because the Wehrmacht logistics system was functional, or because official doctrine was being properly executed. They were holding it because a private wrapped some wire around a broken feed mechanism and hoped it would work. That's not inspiring in any conventional sense. It's not heroic. It's desperate. But desperation that works is indistinguishable from genius when measured by the only metric that mattered that day. Did the gun fire or not? And 60 years later, when historians talk about the MG42's legendary reliability, part of what they're describing is the accumulated effect of thousands of field-expedient repairs by thousands of forgotten soldiers who needed guns to work and couldn't wait for proper parts. The weapon wasn't reliable because of excellent engineering alone. It was reliable because of excellent improvisation, in spite of engineering limitations. That distinction matters. It means that the real heroes of technological warfare aren't always the designers or the generals. Sometimes they're the privates with wire.